Greetings, Earth and Space Explorers. Welcome to Doc Waller's Earth and Space Report for Friday, June 23, 2023. I'm your host, Bill Waller, an astronomer, science educator, and communicator coming to you on a warm and humid summer evening in my hometown of Rockport, Massachusetts. These Earth and Space Reports are intended to engage and inform people like you who are curious about Earth as a planet, who care about our life-sustaining environments, and who wonder about the greater cosmos and all that it contains. Video recordings of these reports are archived on the Earth and Space Reports YouTube channel. They are also in regular rotation on Cape Ann's community access cable television channel hosted by 1623 Studios. I am grateful for the continuing interest and support shown by Rockport educators and students, Cape Ann cultural colleagues, cohorts of the Gloucester Area Astronomy Club, sundry Earth and space scientists, educators, and communicators, far-flung friends, family, and other curious folk. Thank you for your active participation and encouragements. This evening, I'm delighted to be hosting Professor Andrew Fraknoi, who will discuss an eclipse doubleheader preparing for 2 U.S. eclipses of the sun in 2023 to 2024. Professor Fraknoi hails from the Bay Area in California, where he recently retired as chair of the astronomy department at Foothill College. Before that, he served as executive director of the Astronomical Society of the Pacific, where he took that organization to new heights of public engagement, education, and influence. He is the recipient of many awards, including the Education Prize from the American Astronomical Society, the Faraday Science Communication Award from the National Science Teacher Association, the California Professor of the Year Award from the Carnegie Endowment for Higher Education, and the Science Education Lifetime Achievement Award from the National Space Club. Andrew still teaches short non-credit courses on astronomy at the University of San Francisco and San Francisco State University. He has written several books on astronomy, including the free online textbook entitled OpenStax Astronomy, which is now the most frequently used astronomy textbook in the United States. He also has 7 published science fiction stories to his credit, a whole new sideline. He and I have worked together multiple times over the decades, including our co-hosting the highly successful Cosmos in the Classroom Symposium at Tufts University in 2004. In addition to his teaching and writing, Andrew appears regularly on local and national radio explaining astronomical developments in everyday language. With several colleagues, he is leading the effort to distribute 5 million eclipse glasses through 10,000 public libraries across the nation, with support from the Gordon and Betty Moore Foundation. So without any further introductions, the Zoom platform is all yours, Andrew.
All right. Thank you for that very generous introduction. And hello, everyone here and everyone watching us on YouTube. I'm delighted to talk a little bit about the upcoming eclipses and what we're doing nationwide to prepare for what is a remarkable opportunity and also challenge. So let's get the slides up. They're much more interesting than just my face. Let me share my screen. There we go. So as you heard Bill Waller say, we're in for an eclipse double header. And let's take a look. Here are the path of the 2 eclipses we're going to have. I might ask people who are on live to mute their sounds. So
thank you.
We don't
Please
have
mute.
interfering sound. Let's get everyone, if you could, to mute your sound. Anyway, there are 2 eclipses coming, one in October 2023, an annular eclipse. I'll explain what that is in a minute. And then April 8th, 2024, a total eclipse. So what is an eclipse? An eclipse is when the moon covers the sun. By a remarkable coincidence, as seen from Earth, the moon, which is much closer, and the sun, which is much further but much bigger, happen to be the same size in the sky. And this is a coincidence that we've actually investigated now and calculated is only true on Earth. on no other planet in our solar system is any moon exactly the same size as the sun from that planet. Just if you don't believe me, here is an example. This is a sequence of photographs showing one of the moons of Mars trying to eclipse the sun from Mars. And you can see that the attempt is a pathetic failure. Mars, at the distance where Phobos is from Mars, Phobos can't cover the sun. So we're very lucky to have the possibility of total eclipses on the Earth. And when that happens, when there's an exact cover-up by the moon of the sun, the faint atmosphere of the sun becomes visible. You can even see a little bit of the activity, the flames of hot material coming out of the edge of the sun's surface. It's an absolutely magnificent sight. And we'll talk more about that as we go along. The nice thing about an eclipse, the dramatic thing, is that the day turns into night as the sun is covered. Animals get all confused, and you get this very dramatic change in temperature and scenery and the very feeling that you have about your day. And those who have seen a total eclipse say it really is a once-in-a-lifetime experience. So let's take a look at a diagram explaining what I've been saying. So here's the moon, here's the sun, here's the Earth, and the closer moon covers up the sun. Now, it turns out that the orbit of the moon around the Earth is not a perfect circle, and it's not always exactly at the same angle. And so there are actually 3 different types of sun eclipses that we can experience. I've just been talking about a total eclipse, where the moon exactly covers the sun, and where you are on Earth is in the dark shadow of the moon. Then there can be a situation in which the moon is a little too far in its orbit and looks a bit smaller and can't quite cover the sun. It leaves a ring of fire showing around the dark orb of the moon, and we call that an annular eclipse. An annulus is a ring. So an annular eclipse is a ring of fire eclipse where you can still see the outer edge of the sun itself. And then if things are not lined up properly, then the moon can miss the sun, and you get a partial eclipse where the moon may try to cover the sun, but it simply isn't lined up quite correctly. And a partial eclipse also happens if you're not in the right position. If you are seeing a total eclipse on Earth, but you're not right there where the dark shadow falls, then at some different location on Earth, you may still see a partial eclipse of the sun. All of these 3 are things we're going to experience in the next school year. So here's what they look like in the sky: the total eclipse with the atmosphere of the sun showing, the annular eclipse with the dramatic ring of fire, and the partial eclipse, the sun with a big bite taken out of it. All right, and just in case you don't believe me that there is a deep, dark shadow that the moon makes on the Earth, here from an earlier eclipse is a photograph from space showing that deep, dark shadow spot. If you are in this spot, you see the total eclipse of the sun. All right. One thing that people really appreciate about the total eclipse is that nature gives us a little warning just before it's about to happen. Just as the moon slips completely over the sun, the last little bit of sunlight filters through one of the valleys of the moon that are at the top edge here, and you get this brilliant spot of light, and the entire setup looks like a diamond ring. So we call this the diamond ring effect, just before and just after a total eclipse. And that's also something fun to look out for. So what's coming? Well, let's start in chronological order. On October 14th, 2023, there will be this ring of fire annular eclipse in this nice poster made by an astronomer. you get to see that it's especially good in the American West. So he calls it the American West Ring of Fire eclipse. We'll look at a map in a second. October 14th is a Saturday, so that means school will not be in session and families will have a chance to see this together. Again, here's the sequence of events as the moon crosses the sphere of the sun. More and more of the sun is covered, and then eventually the moon just leaves a ring of fire around it. Here's a map of where this annular eclipse will be visible. And it turns out that it starts in the morning of Saturday, October 14th, on the coast of Oregon, goes diagonally toward the southeast, leaves the United States on the coast of Texas, and then makes its way down to Central and South America. So if you want to see not a partial eclipse, but the ring of fire, you have to be in this narrow strip of land that I'm showing you darkened on the map. And within that region, you will get to see the annular eclipse. Here are some cities that are within the annular eclipse zone. In Oregon, where it starts, turns out Portland, the most famous city, is not in the eclipse path, but Eugene, where the university is. And then some national parks, Albuquerque, New Mexico, which is really gearing up, Roswell, which is the UFO capital of the country, San Antonio, Texas, and then on to parts of Central America and beyond. So these are all places you can go. You can see that the annularity starts pretty early in the morning, 9 a.m. In Oregon, 11, almost near noon in Texas, and so on. I'm going to show you in a little while how you can get a free booklet on the web that has all these tables in it. So if you're trying to copy things down, don't worry. I'll show you how you can get all this information for yourself. Here is a map, for example, showing the annular eclipse in Oregon. And for these paths, what's interesting is that the closer you are to the center of the path, the longer the eclipse lasts. So you can see if you're up here, it's only a 2-minute annular eclipse, but in the middle, it's almost 4.5 minutes, or it is 4.5 minutes in the middle. So those cities that are closest to the center get the longest eclipse. But Eugene will have more than 3 minutes of eclipse, which is not bad. The problem will be weather. For all eclipse chasers, the big problem, the big threat is that you're there with all your enthusiasm and equipment, and then clouds come over the sun and you miss the event. So we try to keep track of the weather in the places where eclipses are visible. There's a whole website called Eclipsophile where a weather expert keeps track of these things. And you can see this is the mean or average cloud fraction in October in the various places. And as good as Eugene is in terms of a place to go, turns out there's a 65% chance of cloud cover in October. Whereas if you go to Winnemucca, the cloud cover chances are much lower. And you can see here a graph that shows you different parts of the eclipse path. Odessa, Texas, for example, has low cloud cover chances. Roswell, New Mexico, and so on. So if you are an eclipse enthusiast who is going to be going into the path, please pay attention to the weather. Here's what the eclipse will look like in the major cities of the United States. In most places, it will be a partial eclipse, but depending on how close you are to that path, you might get a pretty dramatic partial eclipse. For example, Houston, Texas will have 90% of the sun covered. San Francisco, where I am, 83% of the sun will be covered. Washington, D.C. will have about a 42% eclipse, which is pretty typical of the percentage of cover up in Washington, D.C., right? No, I didn't say that. If you want to know what the eclipse is like in your community, there's a wonderful website where you can get the answer in everyday language. It's called timeanddate.com. If you go to that and do /eclipse, they have an entire site where every upcoming eclipse, you can put in the name of your city or community, and it will give you a diagram and a table of what the eclipse will look like in that particular location. And it will do so in everyday language and in local time. So you don't have to convert from some astronomical time measurement to your local time. So if you'd like to know what the eclipse will be like for you, just go to that and then pick the eclipse coming up this October. But I want to move on now and tell you a little bit about the total eclipse coming up next April. This will be April 8th, 2024, which is a Monday, so it will be a school day, unless it happens to be spring vacation in your community. And it's a great North American total eclipse because it will be visible in Mexico, the United States, and Canada. And so we will have a continent celebrating this eclipse. Here's the sequence of events that happens in a total eclipse. This is a sequence by my friend, astronomer Rick Feinberg. And you can see the moon begins to cover the sun. More and more of the sun is covered. And then at the height of the eclipse, where the moon is completely covering the sun, the beautiful corona, the outer atmosphere of the sun, becomes visible, something we can't normally see, and the sky becomes quite dark. And then the moon leaves the sun and we resume the rest of our day. So this is what eclipse enthusiasts are thinking about for April 8th. This is an eclipse map showing you the path of the total eclipse, and it translates it into the language of each of the three countries. So in Mexico, they're going to say on the eclipse line, on the eclipse path, fantastico. And it's OMG in the United States. And then with typical Canadian reserve, it's not bad, in Canada. But what this points out is that if you are a true enthusiast, it's only on this narrow path that you'll get to see the total eclipse. Everywhere else, it will be a partial eclipse. You can see the percentages on these different red lines. And for a true eclipse enthusiast, all the other ones are nope, 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 nada, nada, nope. You need to be in the total eclipse path if you really want to see the full drama of the total eclipse. Now, most of the country won't be able to do that, and they will enjoy a partial eclipse. So here is the path now, more clearly delineated. It starts out in Mexico. Actually, the expensive resort town of Mazatlan is one of the best places to see the eclipse. And then it comes through Texas, goes up to Arkansas, and then many of the Midwestern states, up into northern New York. Niagara Falls happens to be a great place for the eclipse. So you can just imagine the weddings that are being planned there. And then on into New England and Eastern Canada. That's the path of the eclipse. There are many national parks in both eclipse paths. So those of you who don't want to pay the outrageous hotel fees that the towns will be charging along the path, you can reserve a spot in a national park and observe the eclipse from there. Here again is a table of those places where the April 2024 eclipse will be total. And you can see that there are a number of places near big towns, so near San Antonio, Texas, near Dallas, near Little Rock, etc. Indianapolis, Cleveland, I mentioned Niagara Falls, Rochester and Buffalo, New York, and on into New England and Canada. These are all places you can go to see the total eclipse, but you need to know exactly where the eclipse will be visible and where it will only be partial. The problem again is weather. The further north you are in April, the more likely it will be cloudy. And here again is one of those graphs where the higher up you are in the graph, the more likely it is to be cloudy. So if you're in Mazatlan in Mexico, It's a great place to observe the eclipse. But as you go into Texas, by the time we get to Texas, it's more than half likely that it will be cloudy. And as you get to Indiana, and as you get then out into the northeastern part of the country, the likelihood of clouds gets worse and worse. So the enthusiasts are all looking to go as far south and west as possible to avoid clouds. Here are some maps of where the eclipse will be visible. I mentioned Mazatlan over here. Again, the closer you are to the center of the path, the longer the eclipse will last. The more you're at the edge of the path, the shorter the time of the eclipse will be. This is Mexico. Then we move on to Texas. So you can see San Antonio itself may not be great, but if you drive north on Route 10 from San Antonio, you get into the center of the eclipse. Similar with Austin. Austin is okay, but if you could go a little bit north, you'll have a much longer eclipse. Fort Worth, you'd want to go south. And then here is Dallas. Dallas will be in the eclipse path, but not ideal. If you go south on one of the routes coming from Dallas, you're more likely to see a longer eclipse. And there are maps like this for every region of the country. The best resource is the website called Great American Eclipse. Michael Zeiler is a retired geographer. He is the master eclipse map maker for the United States, and he does wonderful work free of charge and makes it available to the whole country. So I recommend this Great American Eclipse website. You can get maps for any part of the country showing you what's going on. Here is the 2024 eclipse in major US cities. And again, depending on your location, you get more or less of a partial eclipse. Dallas gets 100%. Washington, D.C. this time gets 89%. Not bad. New York City gets 91%. Los Angeles only 58%. So for each of these, cities, there is a particular percentage of the sun that's covered at the maximum eclipse. And again, I'll show you how to get these tables. So who will see some kind of eclipse in the next school year? When you add together the population of the countries that will be visible, that will be able to see at least a partial eclipse, we come up with 500 million people. And that's a staggering number. Here is an astronomy teacher contemplating the challenge and opportunity of 500 million people needing to learn about eclipses. My goodness, what are we going to do? And those of us who are on the National Eclipse Task Force of the American Astronomical Society have in fact been tearing our hair out and thinking about this. The problem is that whenever any part of the sun surface is showing, even if 90% of the sun is eclipsed, it's not safe to look with your unprotected eyes. Your eyes can be damaged by the intensity of the light, even when a good part of the sun is eclipsed. So it's really important to protect yourself in some way. For example, to wear glasses with special plastic lenses with special material that cuts out the vast majority of the sun. So we'd like to get these glasses to 500 million people, but there's simply no way to do that. Not everybody paid attention in the last eclipse in 2017, even though we warned people all over the media not to look up. Some people still decided to ignore our warnings. We won't mention any names. We'll need lots of safe solar viewing glasses. And we've been thinking quite a bit about how to get glasses out to people. And we realized before the last eclipse in 2017 that many communities have an information distribution center built into their community. It's the public library. That's where people go to get books, to get information, to get online, etc. So we thought to ourselves, how can we involve public libraries? And we talked with the Gordon and Betty Moore Foundation, and they were able to help us. And we had a successful distribution of glasses through libraries in 2017. And this time we went back to them with a very ambitious proposal, which you heard Bill mention at the beginning. We asked if they would distribute 5 million Eclipse glasses free of charge through 10,000 public libraries nationwide. And to our amazement and delight, they said yes, they would. And we are actually in the midst of signing up these libraries now. We have about 4,000 library systems signed up with about 11,000 library facilities within those systems. And they're going to get some glasses, each of them, but they're also going to get a booklet of information about how to view the eclipse safely and what's going on. If your library is interested in joining, and it's still possible, although they need to do it soon, we created a short URL. Just go to bit.ly/glasses for libraries. That's the page where you can get information for your library to join. It's only public libraries, not school libraries, not university libraries. Only public libraries are eligible, but those are the ones that I think have the biggest contact with the public. And as I mentioned, we've prepared not just glasses, but a free booklet for the libraries, which will be printed for them and also available free of charge on the web. And you can also get this booklet. Again, there's a short URL, bit.ly/eclipses for libraries. This booklet has all the charts and maps that I've been showing you in it. I had the privilege of writing it with Dennis Schatz, who is my co-conspirator in many educational projects over the years. And the booklet is now ready. It's there and available on the web. Feel free to print it out, send it to friends or relatives. In addition, we asked the foundation to give us money to train 200 science teachers to be secret agents, if you will, for the eclipse in their communities, to go out and help the libraries and help other community organizations understand the eclipse and observe it safely, to train them before the eclipses ever come on safe observing of eclipses. And we, in fact, only asked for 100 science teachers, but there was so much interest that after 4 hours of having the website open, we got double the number of teachers we could use, and we had to shut down the website. So we asked them to double the number of teachers, and they've just, in the last week, approved this. So we are training 200 science teachers now to be part of this eclipse outreach effort. We also have a booklet for teachers, which is being distributed through the National Science Teaching Association that Bill mentioned. And that's also available free of charge to any teachers or to any of you. It's full of activities, safe viewing instructions, and resources that teachers can use. And it's available at bit.ly/eclipses for teachers. And that's also ready now and available for your viewing. I will mention that through the nonprofit National Science Teaching Association, Dennis and I have written a children's book on eclipses called When the Sun Goes Dark. And so if any of our listeners have kids or grandkids who need a good explanation of the science and the fun behind eclipses, this is a richly illustrated book where we suggest little experiments you can do at home with a lamp and a tennis ball to understand what's going on during eclipses. So this book is available on Amazon or anywhere where good books are sold. It's called When the Sun Goes Dark. We also put together a nonprofit book for teachers. It's called Solar Science. And it's also available from the National Science Teaching Association Press. It's a set of activities, hands-on activities that teachers can do, all about the sun in the sky, eclipses, and more. I should mention a new invention by an astronomer named Douglas Duncan at the University of Colorado. He came up with something called solar snap, which is a filter you can put on your smartphone, which allows you to filter out the dangerous rays of the sun and take pictures of the eclipse with your smartphone. It's dangerous to do that without a proper filter, but Solar Snap enables you to do that. So you can Google that and get it from many different places. One place you can get it where you can also get the glasses themselves, the eclipse glasses, is a company called American Paper Optics. They make a lot of different glasses, including 3D glasses, but they're especially good at making eclipse glasses, and they also distribute this Solar Snap app, which it's both a filter and an app for your smartphone. I don't make any money from it. I just think it's cool, so that's why I'm mentioning it. So here is the typical scene that a person will see during one of these two eclipses. The typical person will see a partial eclipse in the sky, and a typical person will need to protect their eyes. That it can't be said often enough. We also expect that where the eclipses will be especially good, there's going to be tremendous gridlock before or after the eclipse. We calculate that for April, 32 million people live in the path where the eclipse will be total. 32 million already are there. But then millions of others are going to try to get there. And if someone tries to get there the morning of the eclipse, or tries to leave immediately after the eclipse, this is what the typical scene will look like. So if you're planning to go see the eclipse, please plan ahead. Please don't expect to leave right away. We're dealing with crowds unlike anything that, especially the smaller towns in the past, have ever dealt with. And you need to be patient and calculate ahead to give yourself time to reach your desired location. We are actually working with the Federal Emergency Management Organization and with town councils around the country, trying to prepare them for this and make sure they're properly equipped. Number one concern, porta potties, right? If you suddenly have an influx in a small town of thousands of visitors, where are they going to go to the bathroom? You need to plan ahead. So there's a whole subcommittee working on this. You'd think that there'd be some memory of this, but eclipses happen infrequently enough that it's unlikely that the same town will get two eclipses within the memory of one person. And so even though this is by far not the first time that the United States has been crossed by an eclipse, here's a headline from June 8th, 1918, where an eclipse crossed the United States. Nevertheless, most people have no memory of this and need to be prepared. So if you are in your town expecting eclipse visitors, please make sure that your city government, your various agencies are prepared for crowds. Plan ahead is the number one thing that we tell people about eclipses. So there's a great deal of misinformation that gets out about eclipses, particularly in other parts of the world. There are parts of the world where people are told that eclipses produce rays of the sun that are dangerous, special eclipse rays, and therefore everyone must stay indoors during an eclipse. And there's nothing like that. There are no special eclipse rays, but it's the fact that normally people are smart enough not to look at the sun. It hurts. But during an eclipse, your curiosity may overcome your sense of sort of taking care of yourself. And so you might actually stare at the sun, as our former president did, and that's not good for you. So you need to plan ahead to have protection and to know what you're doing. One way is to have these special glasses. Many science stores will sell them. Many schools will have ordered glasses for the school and will be distributing them to families. But in many other places, you may need to buy these glasses at a local science supply store, or science museums will have them, planetariums will have them. Again, not the day of the eclipse. They will run out long before the eclipse actually happens. But if you plan ahead, if you know from this lecture or from something else that eclipses are happening, get those eclipse glasses early while they are still available. All right, but suppose you can't. Suppose you can't get the eclipse glasses. What can you do? I'll show you in a minute some ways that you can see the eclipse safely without the glasses. Before I move on from the glasses, though, I should mention that our sun actually undergoes an 11-year cycle where the sun is more active and less active on its surface. And right now, we're coming in, and certainly in 2024, we will be in what we call solar maximum, when the sun is most active. And that means that if you could look at the sun without an eclipse, it's much more likely that you will see dark areas of the sun called sunspots. Now, normally, the sun is much too bright for you to be able to spot them. But with these glasses, you can see sunspots. So you don't need to have an eclipse to use these glasses. You can use the glasses anytime to look at the sun. And if there's a group of sunspots which is really big, then without any telescope or binoculars, you might be able to spot a little dark spot on the sun, one of these sunspot groups. But as I say, if you can't get these special glasses, there are other things you can do. One thing you can do is to take a hand mirror and make a small hole in the center of it. The hole doesn't even have to be exactly circular. This is as good as someone clumsy like me can do, and it was good enough. And what you do with this mirror is you then let the sunlight fall on the mirror, and you try to angle the mirror to shine an image onto a wall or a screen near you. Something like this. You have the sun hit the covered mirror, and then you shine an image onto the sun to a wall or a screen some distance away, and you will be able to see the eclipsed sun, and you will be able to see the progression of the eclipse going on. And not just you, but anybody with you, family, a class, etc., can see this projected image, and it's safe. You need to cover the mirror and only have a small hole. They recommend about 5 millimeters, half a centimeter. Should be about the size of the hole. And we call this a pinhole mirror. You can set it up on a stand if you don't want to keep holding it, and then have a screen or a wall nearby where everyone can share with you what's happening. Another thing you can do is to have a pinhole projector. You can take a piece of cardboard, put a tiny pinhole in the middle. Some people like to put some aluminum foil in the middle and then make the pinhole in the aluminum foil, which makes the hole even smoother and more precise. That small pinhole will then make an image of the sun on a piece of paper or a wall. And again, people can share that image of the sun with you. So you can project, it's relatively small, but you can project an image of the sun through a pinhole. And there are many instructions all over the web for making a shoebox into a pinhole projector, a big cardboard carton into a pinhole projector. In those free booklets that I mentioned, we give you instructions, and we also point you to web places where there are detailed instructions for making a mirror or a pinhole viewer and projector. So if you don't have the glasses, there are still safe ways of observing the eclipse. And one of our favorite ways of doing this, and one that comes, I think, with many households, is to use a colander. The colander that you wash salads with, or the colander you wash pasta in, is a bunch of little pinholes. And if you hold that colander over your shoulder with your back to the sun and project an image of the shadow onto the sidewalk or a wall, you can see many images of the eclipsed sun. And just the act of standing outside with a colander on your shoulder is sure to attract neighbors and passersby. Who's this crazy person and what are they doing? And then you can share the little eclipse points with others as you're outside. So that's a fun way to share the partial eclipse wherever you might be. All right, well, if you want more information about safe eclipse viewing, where to get glasses, how to make these projectors, the American Astronomical Society, thanks to Rick Feinberg, whom I've mentioned before, who's kind of our co-chair of the Eclipse Task Force, there's a website, eclipse.aas.org, which is the single most reliable and most authoritative place for safe eclipse viewing information. If you're not sure, for example, if a vendor that's selling glasses is a safe vendor, you can go to this website and look up the approved vendors, those that have been vetted and are doing the right thing in terms of the kind of material they use. So if you need an authoritative source of information about the eclipse, I recommend eclipse.aas.org. AAS is the American Astronomical Society, the professional organization of all of us nerdy astronomers. So let me just now mention a couple of other things, and then I'll conclude and have time for questions. But one of the questions that people often ask about the eclipse is, why are eclipses so rare? After all, the moon goes around the Earth every month. Oh, I'm sorry, you pronounce it month, but it's really moon. The moon goes around us once a month. And so shouldn't the moon line up with the sun once a month and cause some kind of total eclipse? And it turns out it's not quite as simple as that. The orbital plane, the plane in which the moon orbits, the orbital plane of the moon is tilted relative to the plane in which we go around the sun. And so the alignment of the sun and the moon is not always such that you can have any kind of eclipse. The moon is most often above the sun in the sky or below the sun in the sky because of this tilt of its orbit. And it turns out only every 6 months or so are the two planes, are the two orbits lined up in such a way that eclipses are possible. You can duplicate this idea at home with two hula hoops. If you have two hula hoops, one representing the sun's motion in the sky, the other the moon's motion, you can see that most of the time the two hula hoops are above or below each other, but twice in the orbit, they come together. Twice a year, which is the orbit of the Earth around the sun, twice a year, the two orbits cross, and that's eclipse season. So every 6 months or so, the eclipse calendar tells us we're going to have some kind of eclipse. And here for the last few years, you see somewhere on Earth, there were eclipses during those eclipse seasons. These are sun eclipses. These are eclipses of the moon, where the moon gets into the Earth shadow. Eclipses like that are only possible every 6 months or so, so twice a year. And we've had a number of interesting eclipses somewhere on Earth every 6 months. But it can be somewhere on Earth. And of course, most of the time, it's not in the United States. And given the surface of the Earth, most of the time it's over the ocean, because more of the Earth's surface is ocean than land. Now, there are many myths about the eclipsed sun. One Chinese myth that I think is particularly interesting and well told is that ancient Chinese asked, why is the sun suddenly eclipsed? There's a dragon that comes and swallows the sun. And what we people have to do is to bang pots and pans together really loud to scare the dragon into releasing the sun from its jaws. And so there's this wonderful tradition in much of Asia that when the eclipse comes, you have to make loud noises and bang pots and pans together. And you know what? It always works. The dragon releases the sun and we come back to sunlight. What have we learned from eclipses? Well, during eclipses, as I mentioned, the atmosphere of the sun, which is usually drowned out by the brilliance of the sun itself, the atmosphere of the sun becomes visible. And over the course of many eclipses in the last century, we've learned about the atmosphere of the sun, the different layers of the atmosphere, the high temperatures in the atmosphere. The outer atmosphere, the glow that you see during eclipses, can be as much as 1,000,000 degrees hot, an incredible temperature. And eclipses give astronomers an opportunity to learn about the outer layers of the sun. So they have a scientific as well as aesthetic value. And I like to show this picture of Einstein laughing, because one of the most dramatic things that happened during an eclipse is that one of Einstein's most outrageous and scientifically wonderful theories was actually proven correct during an eclipse. Einstein predicted in the 19 teens that gravity should actually warp the fabric of space and time. It was an outrageous thing to predict that somehow gravity, strong gravity, could alter, twist, bend, warp space and time itself in some strange way. And Einstein calculated that the gravity of the Earth or the moon or of your little brother, they're much too weak for this effect to be measurable. The only place in our neighborhood where Einstein calculated that this warping effect might be measurable is right near the sun, which has the strongest gravity of anything in the solar system. So Einstein said during the next eclipse of the sun, watch what happens near the sun. Beams of light coming from stars will go by the sun, and they'll be in warped space. Their paths will alter, and those stars will seem to be in the wrong place in the sky as a result. Normally, you can't see beams of light coming by the sun because the sun is so bright. Starlight is weak compared to the brilliance of the sun. But during an eclipse, Einstein realized, the moon covers the sun, stars become visible near the sun, and if you could measure where those stars are, because of the warping of space, the stars closest to the sun will appear to be in the wrong position compared to their normal place in the sky. In 1919, there was just the kind of eclipse where this could be tested. An international expedition went to the coast of Africa where there was an island with the eclipse clearly visible. They made the measurements, and the stars were out of place by just the amount Einstein had predicted. So that's why Einstein is smiling on my slide. Here's the New York Times headline: lights all askew in the heavens. Men of science more or less agog over result of eclipse observations. Einstein's theory triumphs. This was a headline in the New York Times. And here's the diagram of watching the eclipse from the island. This is actually from Brazil. And you see the stars are in the wrong position. And the photograph shows the stars in the wrong position. So eclipses have a long tradition of scientific value as well as being very beautiful things to observe. I'll point out that the next eclipse visible in the continental United States is not coming until August 12th, 2045. That's a long wait. So if you are a fan of eclipses, make sure you see this one in 2024. Well, I hope I've given you something good to chew on here in this particular discussion. I hope that you will be prepared to observe the eclipse safely. And I and the other astronomers here wish you clear skies and good companionship for both eclipses. And now I'm happy to answer questions.
Well, thank you, Andrew, for a masterful explication of what's ahead for many of us. I know many of us have our plans and are making our bets. And I, for one, thought I was going to go to Mexico, but my wife was worried about the Mexico and safety considerations.
Enough said.
And so now I'm thinking of Vermont, which was clear this past April 8th, whereas Mexico was cloudy. And so this is a perfect example of a crapshoot.
Why don't you
Yes,
come
well,
to
it's
Texas
the
with us?
averages. Those graphs showed you the averages of what it's like, but
Yeah.
weather is something, as you say, which is not predictable, not easily predictable. Only the odds can be predicted, and so
Bill,
we don't know
join the
what it's gonna be
APMs
like.
and come to Texas.
Oh, you're going to be in Texas, right?
Right.
And Andrew, you're going to be in Mazatlan, is that correct?
No, I'm going to be in Texas too.
Texas.
I'm going to be in Texas too, and keeping my cosmic fingers crossed. All right, well, Paul, you've been very patient with your hand up. I apologize that I went through the whole lecture, but please ask your question.
Yeah, I was wondering if you were aware of the ham radio efforts and probably other people to study the ionosphere during the total eclipse. You know, you've got basically a night, a day, night, and then day. And they found, you talked about animals get screwed up. Well, so does the ionosphere, apparently. I didn't know whether you were aware of that. I'm sure you must be.
Yes, and so let's tell our listeners what we're talking about. The Earth's atmosphere has a variety of layers in it. And some of the layers are just air, but some of the layers, because of things coming from space, are actually ionized. Ionized means that instead of neutral atoms or molecules, you have charged particles. You have a separation of positive and negative charges. And we call that layer the ionosphere. And when you have charged particles, then the sun's particles and the sun's energy can play on that. And the ionosphere is a complicated place, which is different during the day and at night. One of the things, for example, that you may know that demonstrates that is that if you take AM waves, AM radio, during the day, the ionosphere is all dancing and jiggling with the sun's energy. And so if an AM radio station has its waves go up to the ionosphere, they're just jumbled there. But at night, the ionosphere is much calmer. The sun is on the other side of the Earth. And so the layer of charged particles in the ionosphere becomes like a reflector. And waves from an AM radio station can reflect off the ionosphere and go a long distance. And this is why if you're driving at night, sometimes you can tune in stations that you never get during the day. All of a sudden, stations from much further away are available on your AM radio. It's the reflectivity of the ionosphere. So as Paul points out, there will be experiments underway to study how the eclipse, the sudden no sunlight for a few minutes, will affect the ionosphere. Right. Mario, please, you're next.
Thank you. Great talk. So the American, I'm sorry, the Astronomical Society of the Pacific, I accepted one of their invitations to be an eclipse ambassador, mainly so I can work with some students. And the fourth year Harvard student I'm paired up with. So we're going to go around and give some lectures to inner city and whatever for both eclipses. I already have a lot of my own material, but your slides are great. Any chance we can steal some of your slides? We give you credit, of course.
Sure, you bet. Many of my slides are there in the booklet. But yes, I'm happy. Just let me know, and we can make contact. I'll be happy to provide my slides.
Okay.
And thank you for mentioning this. I should have mentioned that project as well. So the Astronomical Society of the Pacific, which I used to lead, has a very nice grant from NASA to pair up amateur astronomers like Mario with undergraduate students and to train the two of them together to the degree that they need training to become Eclipse ambassadors in their communities. And they hope to train 500 pairs of amateur astronomers and undergraduate students who will supplement these 200 ambassadors that we're training, and other projects are also training people, all to help the libraries and communities understand the eclipse better. So I'm delighted that you're participating in that. I think that's a great project.
Yeah, well, I'll learn a lot from the student.
I think there'll be a great experience for the students to be able to learn enough about eclipses to be spokespeople. We hope that the students will use social media, which they're much better at than we old people, and that they will then get good information out through their channels to their peers and to their communities. And that's really an exciting prospect of getting some assistance, because there are only 6,000 astronomers in the entire country, professional astronomers in the entire country. So we really need help from amateur astronomers and students.
Well, I'll be in Albuquerque for October, and in Bern, Texas, probably move to Kerrville for the center line next April.
Great. You can see all the eclipse enthusiasts are already making plans. In fact, there are places that are sold out along the eclipse path. So if you're interested, it's never too early to get yourself a place or think about where you're going to go camping. And if you have relatives anywhere in the eclipse path, now is the time to tell them how much you've missed them and how wonderful it would be to get an invitation to go visit them. Relatives, friends, alumni from your college, whoever it is, this is a good time to refresh those friendships and get yourself invited to the eclipse.
Okay, I don't know how to raise my hand on the screen.
That's fine. Go ahead.
First of all, the eclipse this year is on my birthday, so it's hard to forget that date. But unfortunately, I'm nowhere near the path. But the 24 eclipse on April, you showed the path going through New England. Is that the total area, or if you were like further south by 100 miles, how much of it would you see?
Yeah, if you're not in the path, it's a completely different experience.
Of course.
Not that it isn't a good experience,
but you get a partial.
Yeah, you only get to see the partial eclipse. And because the rest of the sun is so bright, you don't get to see the day turning into night,
Sure.
the stars coming out, animals freaking out because they weren't expecting it to be nighttime at that particular moment, but suddenly it is nighttime. All those things that go with the total eclipse are only visible in that narrow path.
I was watching the last partial one we had in this area. A friend of mine had a solar 3-inch telescope, so we could look directly at the sun with a partial, and it was really very, very special watching it cover.
That's a good point. So if you know someone who knows what they're doing, or if you're in a science class with a teacher who has a telescope, it is perfectly safe to look at the sun through a telescope if you have a certified, well-attached filter on that telescope that filters out the dangerous rays of the sun. But what a telescope does is it collects more rays than your eye. So if just looking at the sun with your eye is dangerous, looking at the sun through a telescope can really damage your eyes, can essentially burn your eyes out. So no one should look at the sun through a telescope. But if you get the right kind of filter, like Arthur was talking about, and you can either look at the sun or project an image of the sun with the appropriate filter, then yes, even a partial eclipse can be quite dramatic. You can see sunspots and maybe a little bit of solar activity with a telescope that's properly filtered.
Is a welding mask of any value during the eclipse?
Well, I'm sorry, what?
A welding mask.
Yes, welding glass, a welding filter that welders wear is okay only if it's number 14 or higher. Any number below 14 is not safe. And I would say it's very unlikely that the average person will have a number 14 or higher welder's glass available to them. But if you know a welder, by all means, talk to them.
Thanks.
Bill, you were going to say something.
It's worth noting that during totality, if you're really in the path of totality, during totality, it is safe. The sun is safe to view directly.
Yeah.
It's
Yeah.
it's no brighter than the full moon, and you can even look at it through binoculars. But you had damn better know when the
Yeah.
eclipse is going to end.
That's
Done.
really good. Thank you for
Worth
pointing that
going
out.
to this, it's worth going to the center line. This is 2017.
So
Yeah.
look at the beautiful picture
Wow.
behind Mario.
Wow.
Wow, that's a great
A little
picture
godlike.
of the sun. But let's go back to what Bill said, because that's a really important point I should have mentioned, that if you are really in the path of the total eclipse, not the annular, but the total eclipse, during those 4 minutes or 3 minutes, when the moon completely covers the sun, the eclipse sun is not only safe to look at, it's absolutely essential that you look at it. It's one of the
Yeah.
most beautiful things you can ever see, as Mario is demonstrating for us
Yeah.
on his screen.
Fabulous.
So by all means, take binoculars with you if you're going to the total eclipse, and look with binoculars. It's perfectly safe at the eclipse sun. But as Bill points out, the moment the sun emerges from behind the moon, you can't look anymore. But 4 minutes is actually a relatively long time for a total eclipse. So this will be a good opportunity to take a look at the eclipse sun, to see the beautiful shimmering atmosphere of the sun. It's absolutely gorgeous. And when I first showed my wife what this looked like during the first total eclipse we saw together, she wouldn't give me back the binoculars. She just, oh my God, that she's an artist. So she'd never seen it before. She was just enchanted with the eclipse.
Niagara Falls look pretty good.
Another thing to note is that a lot of people are going to want to photograph it, but that can cause you to be more concerned about your photography than the experience. And so you have to balance it. I mean, a person like Mario can, really take it to the next level. And it certainly was worth it. But me, for example, if I have the chance to actually see totality this time around, I don't think I'm going to do much photography. I think I just want to experience it.
Yeah,
Right.
do what I did with this one. You set up a computer program and run the camera through your computer, let it do the work, and you just enjoy it. Just make sure it's centered through the guide scope.
And that's
So
something an experienced amateur astronomer like Mario can do, but most people can't. So I think what
Yeah,
Bill is
touche.
telling us is, if this is your first eclipse and you only have 3 or 4 minutes to observe it, and you spend 2.5 of those minutes fiddling with your camera, you're going to miss a lot of the human experience. So let people like Mario take the beautiful pictures and enjoy the eclipse just the way it is, with your eyes and with all your senses. Listen for the quiet. Look around at the whole horizon and how it's changed. Take in the incredible exclamations from your fellow eclipse chasers. It's really quite an experience, and experiencing that can be in many ways so special that if you waste your time fiddling with your camera, you might regret it.
Yeah, and today the danger is that everybody's got a camera and it's not gonna be protected. And they're gonna be trying to take a picture. All of a sudden the eclipse is over and you got problems.
That's right. If you're trying to take a picture and then the sun comes out, again, you need to look away right away and not take any chances.
Right.
Because your eyes are an incredibly valuable thing that you have in your head. All right.
Well, this has been wonderful. Thank you, Andrew. I'm so happy that you were able to join us.
My pleasure.
Thank you
My
very,
pleasure.
very much.
Great.
All right. Go well. I'm going to shut her down.
Very good. Thank you.
Take care.